In this video, I want to show you how you can expose your Qdrant database cluster running on Qdrant Hybrid Cloud to applications or users external to your Kubernetes cluster, how you can configure TLS certificates for your database, and authentication. By default, if you create a Qdrant database cluster on Hybrid Cloud, the database will only expose through an internal cluster IP service within your Kubernetes cluster. But it's very easy to also expose this outside of your Kubernetes cluster. If you look into our documentation, we document different ways to do this, either, for example, through a load balancer service, through an ingress, or just with a plain port form. Let's look how we can expose the database with a load balancer. I already prepared a Qdrant Hybrid Cloud database cluster running on DigitalOcean. Once the cluster is created, you can go to the Kubernetes configuration section on your cluster detail page, and there is a section to configure the service type. By default, this will be cluster IP, but you also can change it to a load balancer service to instruct the Kubernetes cluster to create a cloud load balancer for the database. Depending on your cloud provider, there are additional configuration options to configure how this load balancer should be configured. For example, if you want to add it to a certain security group, if you want to give it a certain name, if you want to configure health checks, all of that can also be added depending on your cloud provider. For DigitalOcean, for example, there's a huge list of service annotations where I can provide these documentations and configuration. So, for example, if I wanted to change the name from an auto-generated one to some custom one, I could use this DO load balancer name annotation, and I can add this annotation here inside of the service section. And again, there are way more configuration options available that depend then on cloud provider. Best refer to the documentation of the cloud provider you're using for what annotations are available. If I save this change, then the service type will be changed, and in a few minutes, a load balancer will be created. The time this takes depends on the cloud provider. And for example, on DigitalOcean, this will take 2 or 3 minutes. To save us this time, I already prepared a second cluster where I did this configuration already. So you can see here in the Kubernetes configuration section, the service type is load balancer, and I also choose a custom load balancer name. You can also see, if you switch to the DigitalOcean portal here, that the load balancer with the same name is actually created and accepting. What you can also see here is on the cluster detail page that the IP address of the load balancer is actually recognized now and also shown here in the endpoint. And there's even a link to quickly open the database dashboard UI in a new tab on this newly created load balancer. If you click on it, we'll get access to the database. And here you can already see 2 things. The first thing is we don't have authentication set up. And also we don't have a TLS. The Qdrant detail page even tells you that you expose the database outside of the Kubernetes cluster without configuring an API key. So let's change this first. In order to configure an API key, you need to go to the configuration section of the cluster detail page, and we have to reference a Kubernetes secret that holds our authentication information. You don't have to pass in and paste in your API key here directly. You only have to reference a secret that is present in your Kubernetes cluster. So let's first create the secret. This kubectl command creates a secret called myAPIKey with a field called API key, and the value of this field is called top secret in this case, in the Qdrant namespace. You can create Kubernetes secrets not only with the CLI, you can also use any GitOps tool of your choice or use any other secret management tools like HashiCorp Vault that has Kubernetes connections. Now that this secret is present, I can reference this in the configuration of my Qdrant cluster. So I'm going to copy the name of the secret in here, and then the name of the field where my actual value that I want to enter later on when logging in is configured. Save this, and you can see now in a few seconds that the database needs to restart once with this new configuration. And once this is done, let's actually check if the pod already restarted. Maybe it just was too fast already. Yeah, you can see here the pod restarted 16 seconds ago. So it was too fast for me even to see in the UI. And now if I reload the dashboard here, it's actually asking me for an API key. And if I enter my API key, which is called top secret in this case, I can log in into my database. Next, let's configure a TLS certificate. You can configure TLS certificates the same way you can configure API keys by referencing a secret where the certificate and the certificate key are stored in. Again, you don't enter the certificates directly here, you just reference a secret. So let's create a secret first. This command here creates a secret called Qdrant TLS test, and in the secret it will have two fields, a field called cert, which contains the TLS certificate, and a key field that contains the key of the certificate. Again, there are multiple other ways to also create Kubernetes secrets with the tool of field codes. Let's have a look actually at the secret and what it contains. Here you can see the actual YAML specification of the Qdrant TLS test secret, and you can see two fields, tls.crt and tls.key, with the respective certificate and keys. So let's enter this information inside of the Qdrant UI so that the secret is picked up and TLS is configured. So the secret name for both the certificate and the key is Qdrant TLS test, and then the certificate is stored in the tls.crt field, and the key is stored in the tls.key field. Again, let's save our changes, and the Qdrant database will restart with a new configuration again in a few seconds. You can see it's terminating now, and a new container with a new configuration is created, and in a few seconds more it's up and running. Now we just have to wait until the health check is ready and it's done. And now if we refresh here our page, we actually get a bad response because we have to go to HTTPS for the dashboard. And also the link here actually changed, so this is not HTTP but HTTPS anymore. We now get a certificate warning inside of the browser. This is because I just used a self-signed certificate that is not created from the CA that my browser trusts. And this is just for demo purposes. Then I can log in again. By the way, now that we have configured an API key and we configured TLS, we can also create more granular JWT tokens inside of our database. In order to showcase this, let's actually creating some data. So let's go to the quick start and let's maybe create two collections, one called star shards and one called test. And you can see with my admin key that I configured, I have access to everything. I can now go to the access token section here in the UI and create more granular tokens that can either give a user global access or maybe only access to certain collections. So for example, let's choose our star charts collection and allow access to this. And I also want to allow write operations. And click Save. You can see now what is configured in the JWT token. And if I now copy this token that has been generated here, and if I go back to my collections where I can still see both because I'm logged in as an admin, and I now log in with this JWT token, you can see I only get access to the star shards and not the test collection. And I also don't have the permissions to actually create new JWTs. And there are multiple more options that you can do there. You can create payload filters, you can have read-only tokens, and you can create a granular access control system that matches your requirements. And that's it. So what we did do is we created a load balancer for our hybrid cloud database cluster. We explored how we can configure this load balancer to make it internal, to restrict access, to give different names to it, for example. We created an admin API key that we referenced through a secret inside of our configuration. We configured a TLS certificate in our database, and we also explored JWT tokens and how you can use them to support granular access. Thank you very much.